This lecture is on greenhouse gases and global heating. The greenhouse effect, which is mainly due to water vapor and partially carbon dioxide, warms the Earth's surface by absorbing infrared radiation and emitting much of it back down to the Earth. The average temperature drop in the atmosphere is about 33 degrees Celsius, from 14 degrees Celsius average at the surface to minus 19 degrees Celsius at the upper atmosphere. So this figure shows the balance of energy from the Earth. So you've got solar radiation coming in at 235 watts per square meter. Some of that gets absorbed in the atmosphere, and most of it reaches the Earth's surface where it warms the surface. And a warm surface emits infrared radiation, and much of that just gets absorbed in the atmosphere, mostly by water vapor, but also carbon dioxide. And from the atmosphere, some of that gets emitted into space, and some of it just gets emitted back down to the Earth's surface where it cycles around. Okay, and then, of course, some of it just escapes directly to space. So there's a balance. If you look at the total power coming in from the sun, that's balanced by the total amount that is of infrared radiation that escapes from the upper atmosphere. Okay, but the net effect of this cycle of infrared radiation to the atmosphere and then back down to Earth is that it traps heat and makes the Earth's surface warmer than it would be without the atmosphere. Okay, and in recent years, since the Industrial Revolution, there's certain gases in the atmosphere have increased their concentrations. The one you've probably heard about the most is carbon dioxide, and that's responsible for most of what we call the global warming. It's a greenhouse gas that absorbs infrared radiation, and you can see the concentrations. This graph goes back 10,000 years. And we have data on that from the samples of ice cores in the Arctic region. So scientists can actually measure what the carbon dioxide levels were thousands of years ago by looking in ice and seeing how much carbon dioxide was trapped in the ice. So we have that record, and you can see that in recent years, this is on a scale of maybe 100, 200 years or so since the Industrial Revolution started, carbon dioxide has been increasing dramatically in the atmosphere. And other greenhouse gases that are also increasing would include methane and nitrous oxide. Okay, and scientists also have temperature data. These are estimated in various ways, partly also from the ice core samples. And going back, 1,000 years, we have these estimates of temperature, and of course, more recently, we have direct measurements. And what we see is temperatures have been fairly stable for the past 1,000 years or so, and they've started to increase over the last 100 years or so. Okay, up to about increase of close to a degree Celsius by the year 2000. Okay, here's a more narrow range of time, just going back to the turn of the century here, or the last century. And again, you can see the temperature has just started increasing almost linearly here in the last 50 years or so. Okay, now you may hear people say that the temperature change, maybe hasn't increased over the last few years, as if somehow the effect has been stabilized. And you have to be careful because you can always pick a range of data where it looks like the temperatures are constant. So it's very important when you look at data that you're not cherry picking. So it's always more information if you look at a long-term trend than just picking out some short-term sequence of measurements. And here's an example of what I would call bad science. In this article, the authors picked one instrument, one satellite that measures microwave radiation, and then they also picked a fairly short range of data from 1997 to 2015. And, it looks fairly flat there, although, of course, you don't see what was happening right before they started here. Okay. Also, if you see an article like this, kind of look at the kind of stuff they're advertising. And, scientific journals don't have these kind of ads in them, all right? So this is actually the same instrument. It's the RSS satellite in the green graph. This region here was what you saw in the previous graph. And if you look, of course, at the longer trend, you see that it does show a pretty steady, actually almost linear increase of temperature here, which is more or less in agreement with other instruments. You've got change of temperature this is relative to some average here, so it went from minus 0.3 up to about 0.5. So that's in degrees Celsius. So that's about 0.8 of a degree Celsius over the last 40 years or so. So pretty dramatic increase, actually. Okay. Some people seem to think that it has something to do with solar activity. So this is a graph of the temperature changes in red and the solar irradiance, the energy intensity from the sun. And you can see they maybe look a little correlated back here in the 1920s and 30s. But more recent times, the temperature keeps going up, even though the solar irradiance has stayed fairly stable. Okay, this is a graph from the IPCC, the Intergovernmental Panel on Climate Change. And this particular graph only shows kind of two different models. One is a high greenhouse gas emission scenario where we keep putting more and more carbon dioxide into the atmosphere. And you can see they're predicting by 2100 that would yield to a 4 degrees Celsius increase of temperature. That's about 8 degrees Fahrenheit, which is quite a lot for the whole planet to warm up by that much. And then the blue line is what would happen if we really mitigate our greenhouse gas emissions and try to keep the temperature low. And they're basically just saying that the models show that it is possible to stabilize the temperature increase. Besides temperatures going up, we also have the sea level rising. If you look over the last 100 or 120 years or so, sea levels have gone up about 20 centimeters. So these are in millimeters, I guess. So anyway, roughly about 20 centimeters. And just keep going up. So a big threat of global warming is the rising sea levels will have a really devastating effect on coastal cities. Okay, if we look at the effect in the Arctic, these are some pictures of sea ice. They're all done in September, and I picked out 3 different years here. Notice in 2002, you've got pretty full ice coverage. And then in 2012, you have much, much less, maybe just a little more than half. And then the next year, 2013, it seems like it's all recovered again. So there's quite a bit of variability. And depending on which years you pick, you could say that the ice is decreasing dramatically or the ice is increasing dramatically. Okay, so again, it's important to look at the long-term trends, which is what I have in the graph here. And the long-term trend is a steady decline in the ice in the Arctic. Okay, another problem with extra carbon dioxide in the atmosphere is what's called ocean acidification. When carbon dioxide dissolves in seawater, it forms what's called carbonic acid. So it makes the ocean more acidic. And the three quantities that are plotted here are the carbon dioxide intensity, which is in red, and then the seawater concentration of carbon dioxide, which is in green, and then the pH, which is in blue. So lower pH means more acidic. So the seawater is getting more and more acidic. And this is happening, globally. And in places like Washington State, it's affecting the shellfish industry, where people growing shellfish, actually they send the eggs down to Hawaii, where the water is less acidic in general, and they let the young shellfish grow to a certain age, and then bring them back to Washington, where they can tolerate the more acidic water. Okay, so some predictions of the increased carbon dioxide levels are by 2100, you might have surface temperatures going up, roughly between 2 and 6 degrees Celsius. Glaciers will mostly disappear. They're already receding rapidly. The Arctic ice may completely disappear in the summertime. And already this is affecting the global economy, because in the summer now shipping lanes are open in the Arctic that never used to be open. With more energy in the atmosphere, more heat in the atmosphere, we expect more hurricane and typhoon activity. As I just mentioned, we expect the oceans becoming more acidic. And it's not really clear what that will do to the plankton and algae in seawater. It may actually affect the marine food chain. It's expected that species will have an increased rate of extinctions, because some of them will not be able to adapt to the new climate conditions. Forests are being destroyed. Partly that's because places that used to freeze in the winter may not be freezing now, and so pests, insects that used to die down in the winter from the cold, will be more destructive, because they don't get that cold weather to kill them off in the winter. That's a big problem right now in Canada already, and also the Pacific Northwest. With warmer temperatures spreading further north and south from the equator, we expect tropical diseases to keep up with that changing temperature. So increase of tropical diseases. And then the sea level could rise as much as several meters due to melting ice in Greenland and Antarctica. I mentioned earlier the Arctic ice, that's already in the water. So that having that melt doesn't actually change the sea level, because that ice is already floating in the water. So that the weight of that ice is already there. But ice melting from land in Greenland and Antarctica could cause a very large rise of sea level. And just to put that in perspective, Portland, Oregon, or Vancouver, Washington, the river there is about 7 feet, or just over 2 meters above sea level. So if the sea level goes up, more than a couple meters, then Portland, Oregon, and Vancouver, Washington will be, on the seacoast. So some methods for limiting carbon dioxide concentration would be reducing energy usage, using non-carbon based sources of energy, such as nuclear, solar, hydroelectric, wind, or geothermal. It's also possible to use fossil fuels but capture the carbon emissions and maybe store them underground or something. It's an option. And finally, in deforestation, start planting more trees, because as trees grow, they absorb carbon dioxide from the atmosphere. And of course, if you burn a log, you're taking all that carbon and putting it back up in the atmosphere. Okay, this is a chart of carbon dioxide emissions per capita, so per person, in different countries. You can see that the United States and Canada are up at the top end of the chart here, along with Australia and Saudi Arabia, countries like that. I think there might be Kazakhstan there. So these are very high energy using countries. And it's really quite amazing. You know, places with comparable levels of development, like Europe or Japan, use maybe half as much energy per person as we do in the United States. So clearly there's room for improvement. One difficulty in trying to limit the carbon dioxide emissions is that developing nations like China and India are increasing their emissions as the economies grow. So, you know, more and more people buy cars, for example. So that combination of increasing development and also increasing population makes limiting CO2 emissions very difficult. Here's a list of 10 goals that the United Nations has set out for sustainable development. These include sort of, first of all, political ambitions, like getting nations to commit to more ambitious goals. They want countries to commit to being carbon neutral by 2050, so stop increasing the amount of carbon dioxide in the atmosphere. Also, look at new sectors such as what they call nature-based solutions to problems. Let's see, fourth is to have a just transition, you know, just meaning fair, a fair transition for people whose livelihoods are impacted. Fifth would be curtailing coal usage. They want to stop anyone building new coal power plants. Six is accelerating the transition to 100% renewable energy. 7 is financial, so shifting financial flows from, you know, basically fossil fuels into renewables, pricing carbon, and also finding sustainable ways to finance that renewable energy. Support for people affected by climate change, and a shift towards a resilient future. 9 is delivering on commitments to small islands, developing states, and least developed countries. So as sea level rises, you know, obviously the first places that are affected are the small islands in the oceans. And then finally, decarbonization of key energy or key economic sectors. Okay, so those are the United Nations goals. And there's also a list of things that individuals can do really without much investment. So here's a list here: 5-minute showers or less, driving less, turning lights off, using local produce, refilling and reusing containers, meat-free meals, zero waste fashion, bring your own shopping bag, recycle, and unplug devices that are not being used. Okay, so that's a summary of greenhouse gases and global heating.